Hi everyone, good morning. Okay, so till yesterday we discussed about Git and what are the frequently used commands in Git and how we push and how we pull the code and how we resolve the conflicts. Okay, so what is the Git workflow? So all these things we have discussed. So still there are a few more things that needs to be discussed on Git, but whenever those are required, I will introduce those topics. Okay, so now let's start with our next topic, Docker. Okay, yeah. So Docker is one of the tools used in DevOps. Okay, uh, basically Docker is also it's just like a EC2 machine. Okay, so it's like a machine only. So like machine, what a machine should have? A machine will have hardware. Okay, machine will have hardware, OS, and softwares. So here you will have softwares. See, hardware, OS, and these are softwares. Okay, so here a, a Docker is also just like a machine only. Okay, so I will explain what is the then Docker is also same as EC2 instance. Then what is the difference between EC2 and Docker? I will explain. Okay, first of all, before going to understand, we have to understand what is container. Okay, so we call it as a Docker container. As few people call it as a container. Docker and container both are same. Okay, so let's try to understand the terminology. So in basically Docker, with the help of Docker, we can create the containers. Okay, so here this is the container. Okay, so a container is a machine. It's the same as an EC2 machine only, but it is a virtual machine. So with the help of Docker tool, we can create the containers. Okay, let me write here so that you will easily. Okay, first understand containers. Containers. What is container? A container is a machine which is same as machine. Container is same as EC2. It's like a normal machine only. Container is same as machine only. Virtual machine. What a machine will have, guys? A machine will have operating system, hardware, and the softwares. That is called as a machine. Virtual machine. Oh. So what is Docker? So Docker is a tool which is used to create number of containers. Okay. Here we should understand the three terminologies. So the basic three. We'll discuss these three terminologies today. this. OS level virtualization. Okay. OS level virtualization. Number 2, layered file system. Number 3, union file system. Union file system. Okay, so these are the most important terminologies that we have to understand. What is OS level virtualization? What is layered file system? And what is union file system? Okay, all these things we will discuss in today's session. So here, have you anyone observed what is container? See, if you type Docker here, so here, if you observe Docker, so how it look like? It look like a ship or not? This is the ship, okay, and it is having all the containers. Every box is called as a container. So the word Docker is taken from shipping. Okay, so it is taken from shipping container. The name come from shipping container. Why? Because a ship contains lot of containers. In the same way, Docker is also used to create number of containers. Okay, so in which in container, what in container we can put in the ship, so we can whatever the uh, objects we want to transfer from one place to other place, those items will be used in the containers, and all the ship will take these containers from one place to other place. In the same way, Docker is used to create containers. What the container will have, in the containers we can deploy our applications. Okay, so anyway we are doing the same thing in our machines now, then why are we using this Docker and container concepts? So that you will understand slowly. Okay, so in the development, basically how many number of stages are there? First is design stage, second one is
Coding.
coding or development staging, and the third one is deployment, and the fourth one is unit testing, and the fifth one is delivery and monitoring. So like this, we can differentiate that into 7 stages or 5 stages. But on an average, we can say that first is analysis or design, second one is coding or development, third one is deployment, fourth one is unit testing and all. Once unit testing and all is done, then it is ready. The application will be ready. So here, where this Docker comes into the picture in the all 4 stages or 5 stages, in the deployment stage, the Docker will come into the picture. Okay, so Docker will be used in deployment phase. Why? With the help of Dockers, we can create the containers. In the containers, we can deploy our applications. Okay. Now let's try to understand what is VMware. Have you heard the word called VMware? Hmm? Have you heard the word called VMware? VMware or Virtualbox? Or Virtualbox. So what is VMware and what is Virtualbox? Any idea? No idea?
No, sir.
No, very good. So let's assume so the cloud concept is not there. Okay, you are having a Windows machine, you are having one laptop, so in which you have installed with Windows operating system, obviously. Okay, so as part of some course or some your interest, you wanted to learn some Linux or Ubuntu or whatever it is, you want to learn something. So in that case, can you install Linux in your machine? I need answers, guys. Can we install Linux in your machine?
Yes, sir.
The answer is no. We cannot install Linux in our machine. Why? Because one system should contain only one operating system. If both operating systems are there, then the hardware will can the hardware understand operating system of Windows or Unix? What is operating system? So operating system is nothing but a intermediary person between you and the hardware. Okay, so when operating system is installed, so that is the first software in your laptop. Okay, so that it will create an environment so that you can whatever the instructions you give that will be directly communicated to the hardware devices. So if you install two operating systems, how it will be working? It will not work, right?
Yes, sir.
We cannot create two operating systems in one machine. That is a very basic. We have to understand that. Okay, yeah. So but you want to practice your Linux commands and all. So as of now we are using cloud. So in the virtually we are launching one instance with whatever the operating system we want, and we are practicing our commands. But if the cloud is not there and you will be having only one machine, what you have to do? You have to remove your operating system completely, and you have to install Linux, and you have to practice. Once your practice is done, again you have to remove that OS, and you have to install Windows back, and you have to work on Windows. This is how you have to do that. So this is not a good practice, right? So for that purpose, there is a concept called VMware. Okay, so one software will be there, VMware or Virtualbox software will be there. Okay, so here what happens is, okay, so this is just like, so here you will install, this is your machine, this is your complete EC2 machine or your laptop. Okay, here what are the components you have? The first one is hardware. Second one is OS. So this is the basic machine. You will be having hardware and OS. So on top of it, what we have to do is we have to install some VMware softwares. VMware or virtual, we can call it as a Virtualbox. There are different VMwares are available in the market. So Oracle VMware. So here you have to install VMware. Okay. VMware. Okay. So after that, once VMware is installed in your machine with the help of this VMware software, you can create multiple machines, multiple virtual machines in single system. You can create multiple machines. So you can create like this. This is one system, and this is one system. Okay. This is machine 1, this is 2, this is 3. Okay. So here, this is your OS. Once you have installed your VMware, you can install OS in the VMware. You can create multiple machines, virtual. Okay. So this is OS with Linux, and you can create one more machine. Here you can install OS with Red Hat. Here you can install OS with Solaris. Okay. So here, once OS is installed, so you can install whatever the software you want. Got it? So like this, you can create multiple machines in a single machine. Okay. Any doubts? So here, this is one machine. Okay, so this is one machine. This is virtual machine. This is one virtual machine. The same thing will be happening whenever you are trying to create any instance in AWS cloud. Same thing will be happening. So they will be having one system. In that system, they will be having one VMware. So with the help of that only, they will be creating whatever the machine you want, with whatever the configuration you want. With that configuration only, they will be giving you the instances. Okay. And this is with VMware concepts. Now let's assume without VMware, how can we do that? With the help of Docker. Okay. This is Docker. Okay. Yeah. So here, if you observe from here to here also your machine is having hardware. Here also another person's machine is having hardware. Here operating system needs to be installed. Here also operating system needs to be installed. If we want to create one virtual machine with our own software and all, so here we have to install VMware. Instead of VMware, here we have to install Docker. Okay, on OS in your machine, you have to install one Docker, one software called Docker, one tool called Docker. Once Docker is installed, then you can install whatever the applications you want. But here, no, you no need to, you are not supposed to do that. Here, you have to install OS first. On top of OS, you can install the software. Okay, got it? Did you find the difference here? Here, when we install VMware, we have to install OS, then only in that machine we can install softwares. Without having OS, that machine is not going to accept any softwares. But in case of Docker, we no need to install operating system separately. Once the Docker is installed in your machine, we can directly in the Docker, we can create the containers. This is one container here. Let me draw in a different way. Okay. Yeah. Now, Docker, and after that, this is container 1. This is container 2. In container 1, we will be having different softwares. Software 1, application 1, application 2, application 3. And here also we can have different applications. Okay. So here, do you see the differences now? Here, once we call the soft Docker installation is completed, we can create multiple containers. Each container can have its own applications or own softwares. Here also same thing. Once the VMware is installed, we can create multiple machines, and each machine can have its own applications and its own softwares. Here and here the difference is, here we are calling it as machine, virtual machine 1, machine 2, machine 3. Here we are calling them as container 1 and container 2. Both are same one. What is the difference between this container and this machine? Here, in order to work these applications, in order to work this software, we no need to install any operating system. Without operating system only it will work. But here, without installing the operating system, we are not allowed to install any applications. Okay. So here to here, what is the difference? Mean the operating system is the difference. Without operating system, with the help of Docker, the applications will work. How it will work, I will explain now. Okay. And if we observe the advantages and the disadvantages here, let's say your system is having 12 GB of RAM. Okay, 12 GB of RAM. So whenever you are creating 3 machines, you have to allocate some memory. 4 GB of memory for this, and 4 GB for this, and 4 GB for others. Like this, you have to allocate. Okay, so why? In order to install OS, it should have some memory, right? Out of your plate, you are dividing that plate into some different parts so that it will occupy the space from the main only, right? So this is the main, from here only it will take the memory. So here the drawback is, once you have assigned 4 GB of RAM, even though it may not use 4 GB of RAM, but the unused memory will not be deallocated at runtime. Got it? Please respond.
Got it, sir.
Okay, once you have assigned the memory, it will not be deallocated. Even though, let's say while creating the one virtual machine, you have given 4 GB of memory. So, but after installing, if you observe, it may take only 1.5 GB only. So you cannot take that back again. 2.5 GB, that is unused only. So like this, here it will take more memory. When it comes to Docker, here there is no concept of installing OS. In that case, then where is the question of allocating the memory, and where is the concept of wastaging them? So we can save more with the help of this virtual machine. If you have 12, so we can create only four machines or 3 machines, not more than that. But here with the help of Docker, we can create more number of containers when it compares to VM machines. Okay. Okay. So now see how this Docker works without operating system. How this Docker works, we'll see that. Okay. So okay, this is your instance. Okay, so here your machine is having okay. Let me draw this diagram first, then we'll see. Okay, here this is your local machine. Okay, so EC2 machine, for example. Okay, here as usual, it will have hardware, it will have OS. What is the OS? Let's take Linux OS, CentOS, Red Hat OS, or Ubuntu. Let's take Ubuntu. Ubuntu. We have installed with operating system as Ubuntu. So now here I am installing our Docker concept. I have installed a tool called Docker. Okay. Now how it is going to work, we'll discuss now. So before going to understand this, so if we go back to our initial sessions, we have discussed about what are the different types of operating systems are available. What are the different types of operating systems available? Come on, guys, you remembered about
Linux, Red Hat,
there are basically two
Linux,
operating
Red Hat,
systems are there. One is
Azure.
Windows, and the second one is
Linux,
Linux.
Unix, not Linux. Windows and Unix, only these are the two operating systems are there. In the Unix, there are the different flavors are available. One of the flavor is Linux. Okay, so Linux, you have to remember, guys, all these things. You forget how. That is the reason I have explained by taking complete one section about only operating systems. In Unix, we will be having different Linux, Mac OS, and also we have Solaris, etc. Like the different are there. Are these called Linux, Mac OS, Solaris, HP? What are all these OS called? All these operating system called as these are the flavors of Unix. All are Unix only, but everyone this Linux is done by some other Linux Torvald person. Mac OS is done by Apple. So everyone will be having some different minute 5% of the changes. So this is why the base is Unix only. Okay, whatever Unix is there, so the base is Unix. Everyone taken from Unix only. They have taken it from Unix and they have added their own changes. So that is the reason all these are called as these are the different flavors of Unix. Okay, if you observe from Linux now, okay, even in Linux also, someone has taken this Linux version. So they have taken this Linux version and they made their own changes. Okay, what are those?
CentOS, Red Hat, Ubuntu.
CentOS, Red Hat. So like this, different versions are there. So where they have taken their source code, did they taken that source code from Linux or Mac OS or Unix? They have taken the source code from Linux. Linux is the source code. On top of it, they have added some changes in CentOS and Red Hat. So that is the reason these operating systems are called as Linux flavors. Okay. Here from Linux to CentOS, what are the, I mean, what percentage of changes we can identify? It's ridiculous, guys. From Linux to CentOS, we can identify only 5% of the changes only. Okay, so because they have taken it from Linux and they added their own changes, so 95% is similar only 5% changes we can identify. So here what will happen is So whenever we have installed this Docker, whenever we install Docker, what it will do is, so already this is having Ubuntu operating system, and you want to work with here, you want to work with Linux. This is Ubuntu, and you want to work with CentOS. Okay, so here what it will do from Ubuntu to CentOS, there will be only 5% of the changes only. Okay, remaining 95% is same. So when 95% is same, it is already this operating system Ubuntu is taking 2 GB of memory. This CentOS is also taking 2.1 GB of memory. So, but out of which this Ubuntu and CentOS 5% changes only identified. Remaining 95% is same. So that means only 100 MB is occupied for those changes. Remaining 2 GB here and here same. Okay. So if I install CentOS separately, again this will take 2.1 GB of memory. Instead of wasting that 2 GB which is already there here, what this Docker will do is, this Docker will utilize that OS, the CentOS from here only. Whatever the 95% common piece is there, that common piece will be taken from your main operating system only. How the Docker will know whether this 95% is taken from there or not? So in the Docker software, there is a concept called Docker Hub. Okay, so there is a concept of Docker Hub. In the Docker Hub, what it will do is Docker image 1, Docker image 2. It will be having images. Okay, so this is the Docker Hub, like GitHub. Docker Hub. So this Docker Hub contains all the images. These images will be having that 5% of the changes from one OS to other OS, whatever the changes are there. So that final variant, whatever the variance is there, whatever the differences are there, that differences will be stored in these images. Okay, so what it will do is, whenever you are installing the CentOS, it will take the image that is related to CentOS. Okay, so here it will take the Docker image. Okay, so because of this Docker, whenever you are creating this container, whenever you are creating this container on the Docker, it will take the Docker image from the Docker Hub. Okay, so now this will be having the 5% and this will be having a 95%. So now, in order to deploy our applications, in order to run our applications, in order to work with our softwares, whatever the operating system is there, is that requirement fulfilled or not? Yes, it is fulfilled. How it got fulfilled? The base is having 95% and the remaining 5% is available in this Docker image. So now this Docker will coordinate with 5 plus 95 and it is available 100% of operating system. And in this container, we can create whatever the applications we want, we can deploy whatever the applications we wanted to deploy. Like this. Here also, you want some Red Hat. Okay, so it will take the required 5% changes from where? So the Docker knows that here you are having operating system. You want to create a container with kind of Red Hat operating system. Okay, so here, so this Ubuntu and Red Hat, so it will know the difference. This Docker software will know the differences, right? So 5% is missing now. So it will get that 5% from this Docker Hub. So that here also it will take the required image. Okay. Okay, so here also it will take the Docker image. Now here also it will be having 5 plus 95%. Total 100% of code is available. Okay, so now we can deploy the applications in this container. So here we are not installing any operating system manually. From here only it will be taking, it will be having the operating system, but it is taking virtually. So this concept is called virtualization. Okay, operating system virtualization. We have discussed the first term, right? This is OS level. So what we are doing, we without installing operating system, still we can do whatever we want. So here this concept is called operating system level virtualization. Is this clear? Any doubts?
Clear, sir.
Okay. Any doubts?
Clear, sir.
No. So ideally you should have doubt if you are smart enough. So here we are
Yes, sir.
using the operating system of Linux. So Linux to Linux, so there will be 5% of the changes. So that's how it will work. But when it comes to, I have my Windows machine. If I use Windows machine, this Windows to Linux, 100% changes are there. Then how it will work? Again, here I have to install the complete operating system of Linux, right? No one got that doubt? Okay, cool.
I got the doubt, sir. Same doubt.
So here, so basically Docker images, I mean Docker concept will be used only on the Linux machines. 99% of the times it will not be installed on the Windows machines. Okay. So even if you install, it will take the Docker images and it will do that. Okay. So recently they started giving support for Windows also.
Sir, can you repeat once?
Basically this Docker and all these concepts will be used in Linux environment only, so it will not be supported for Windows earlier, but now they started supporting for Windows also. In that case what it will do is it will not take the complete memory when compared to this one. Okay, so it will dynamically take the memory from here, so you need not to give the memory, you need not to allocate the memory whenever you are installing any operating system. Okay. So let's say, as I said earlier, if you allocate 4 GB of memory, but it is not using complete 4 GB, the remaining GB is wasted. But when it comes to Windows, when if you work with, if you start working with Docker, so it will automatically allocate and deallocate the memory. Okay, that is how it will save some memory. Okay, yeah. So here, this is the Docker image. So on top of it, you can install whatever the applications you want. So this is the Docker image. This is the first one. So after that, so whatever the softwares you want, you can install them. So here, okay, okay. So yeah, here. So here, if you install one application, let's say you have installed one application called, what is your application? Let's say you have installed VLC player. Okay, you have installed one more application called, can anyone name any application? You have installed one IDE. Okay, you have installed Git. Okay, you have installed Ansible. Like this, you can create, you can install n number of applications in this container. This is container only, right? We call it as container. Once the Docker is created, we call them as containers. In this container, you can install, you can deploy any applications. So each time, whenever you create an application, a layer will be formed. So on, this is the first layer. After this, whenever you are going to install another application, it will be created another layer. After that, if you want to install one more application, it will create one more layer. So here, all the applications are deployed one after other, one after other. It will form a layer. It will be available in the form of layer. So that is the reason this file system is called as layered file system. Okay. So once you are done with your container, you have one Docker. In the Docker, you have created one container, and this container is having 10 applications. Okay. Yeah. Here, the good thing is from this container, for this container, you can create one image that is called as, let's say, this guy is there. This is the Docker image. Okay. So if you create a Docker image for this, this is then another guy, this is you, and this is another guy. Okay, this another guy is also wants to have the same set of applications. He wants to have Ansible, Git, IDE, VX, and whatever the 100 applications are there. All the 100 applications needs to be available in his machine also, in his image also. In that case, what he has to do, he has to create the container, and in that container, he has to manually install all the applications. So doing that manual creation of applications is not a good practice. So that is the reason what this guy will do. He will take the image, respective image from this Docker Hub, so that once he get the Docker image from the Docker Hub, all the applications that are installed on that particular container will be available here also. On top of it, he can add whatever the remaining applications are needed. He can add those applications. Okay. Got it or not? So we can create the Docker image. Once the container is created, we can create the Docker image. What is the Docker image? It's just like a replica. It will be having the snapshot. If someone takes that snapshot, they will also get the same set of applications, whatever the Docker image is having. Okay, so we no need to do anything. Okay, and we can completely take the Docker image only, but we cannot take only Ansible, Git, and IDE is needed, and VLC and remaining are not needed. So I will take the Docker image with only these Ansible, Git, and IDE. Only with these three applications I want an image. That will not be happen. You can take, if you take the Docker image, whatever the applications are there, are created in the container, are available in the container, all those applications will come together. That is the reason it is called as a union file system. We cannot remove while taking the Docker image. Once you have taken that, you can undeploy those applications. That can be done. But while taking it from the Docker Hub, we cannot change the applications that are already available in the Docker image. Is that clear? Okay. So when this Docker concept is useful, let's say there is one team is there. In that team, you need to create 100 EC2 machines with so and so configuration and all. So in that case, which one is the better approach? Is it better to create EC2 separate EC2 machine with separate 4 GB of RAM, or with one operating system with one RAM? Is it better to create multiple containers? Here one machine is there. Okay, so one machine is there. So this RAM, this memory, I mean whatever the hard disk is there, whatever the RAM is there, so that will be shared by all these containers. In each container we can install the applications, we can do whatever we want. Okay, so here if we create 100 containers, means 100 Docker images can be created and 100 persons can work with those containers, just like 100 virtual machines only. But if we create 100 EC2 instances, what we have to do? We have to take 100 operating systems separately. So every machine will have an operating system. And let's say if that Linux machine is going to take 2 GB of memory, if you launch 100 EC2 instances, every machine will take 2 GB, base of 2 GB. So 2 into 100, 200 GB of memory is only taken for your hard disk only. On top of it, you have to create the container. But if you only take one machine and if you install Docker, do we need to take that 100 separate Linux operating systems? We can directly use the base operating system, right?
Yes, sir.
Okay. So that
Yes,
is the
sir.
advantage. That is one of the use case. 100 machines are there. First machine is having Linux operating system. Second machine is also having Linux operating system. First machine and second machine. Is there any change in the operating system? No. First machine is occupying 2 GB of memory. Second machine is also having 2 GB of memory. If I want to launch one more instance, that should also have 2 GB of memory. But I don't have provision to use from the already available. It is already there in first machine. Can I use it from the first machine? No. I have to launch it separately. Why? Because there is no linkage. If I have the Docker, I can directly use the operating system which is already there. If I want to do something else, I can get the changes from the Docker Hub.
Docker Hub.
Okay, so in that case, I can save some memory. So that is one of the use case. Okay. Any doubts? Okay, if you guys have if you don't have any doubts, then we'll end this session for today and we'll discuss the remaining topics tomorrow. Yeah.